Now this is a Davisson Germer experiment which provides an experimental evidence for the existence of matter waves. Now this experiment consists of an electron gun in which you are having a filament. That filament can be heated using a battery. Once it is heated to a sufficiently high temperature, it emits electrons due to thermionic emission. These electrons can be accelerated to a particular potential using an applied potential difference. The electron beam is made into a narrow pencil using two slits S1 and S2, and then this electron beam is made to incident on a target. The target is made up of nickel and with a particular inclination, and then it can be rotated in any direction using this knob, and also the electron beam is deflected by some angle, and the electron beam can be detected using a Faraday cylinder, which is basically a detector of electrons. Now this cylinder is provided an arrangement wherein it can rotate on a circular scale, it can move on a circular scale. The circular scale is divided into degrees and minutes, and so that you can place it at any particular angle. Now this cylinder is connected to a galvanometer. As soon as it receives a electron beam, the galvanometer shows a deflection. The intensity of electron beam can also be detected by knowing the reading in the galvanometer. That is the experimental arrangement. Now once this electron beam is emitted by the filament, it is made to incident on the nickel target and it gets deflected. We observe the electron beam by knowing the reading in the galvanometer. It is observed that the electron beam has a very large intensity when the applied potential V is equal to 54 volts. And the angle of deflection theta is equal to 50 degrees. See, when the angle of deflection is 50 degrees and when the applied potential is 54 volts, the electron beam intensity is maximum. Using this data, we can calculate the wavelength of the electron beam. See, the electron undergoes diffraction here. Diffraction is basically a wave phenomenon. Diffraction is exhibited only by wave, and here the electrons is undergoing diffraction. How we can confirm that is, if you use a diffraction principle and try to find out the wavelength using the given data, we will get the value 0.165 nanometers for the electron beam. That is using diffraction principle. Now on the other hand, if we use matter waves concept, the wavelength of matter waves lambda is given by 1.226 divided by square root of V nanometer, that we have seen in the previous topic. The wavelength of matter wave is given by that expression, and V stands for the potential difference, applied potential difference. Here in this case V value is 54. If I substitute 54 here in this place of V, what I will get is lambda is equal to 0.165 nanometer, which exactly is equal to the value which we obtained using diffraction principle. It implies that this electron beam is undergoing diffraction, which is basically a wave phenomenon. Electron is basically a particle, and in this experiment it is exhibiting diffraction. Diffraction is a wave phenomenon, therefore electron is exhibiting the wave nature. This is an experimental evidence for the existence of matter waves.